It's episode 4.
Even if it were made out of completely normal materials, there's quite a few things about this build that are quite tricky. I think it's going to be a long haul. If you do carry on following my progress, here's what I hope you will see. First, I need to move the sewers. This is the public sewer running through my yard, and the connection from this flat and the flat above it comes from here, across here to a manhole, and then across here to join the sewer. And this manhole is in the way of the new structure, so I'm going to have to move it in this direction. Next, I'm going to have to sort out rainwater drains, so that there's a gully drain around the outside of the new structure, and something to take the water from the roof. Then I need to dig the trenches and pour the concrete for this strip foundation. At this point, I'll probably prefabricate the entire timber structure of the building, but do it at the other end of the yard so it can be dropped onto the footing once it's finished. Then I'm ready to demolish the old extension and the garden wall. Once the demolition goes ahead, I'm really on a time scale because I need to put the footing walls in, drop the timber frame on, and get the brick cladding up, all within a window of time defined within the party wall agreement. Party! That shouldn't be a problem, but it's the reason for prefabricating the timber frame and dropping it in ready-made. Once I've demolished this part of the garden wall, I need to make alterations to what's left of it, because these upright pillars aren't in the right place at the moment, and I will already have supported the old foundations on my new foundations. Then it's time to build the new footing walls onto the top of the strip foundation. Now, you can design a hempcrete wall by putting the timber frame on the outside of the wall, in the centre, or on the inside, and each has different benefits. But I've gone for putting the timber frame in the centre of the wall. And that means that the footing has to be designed a little bit differently than it would be if you were designing a brick cavity wall, because the load of the timber frame is in the centre where the cavity would normally be. So that means you need to make a solid footing. Use a damp-proof membrane to keep the moisture out, and then to provide the thermal insulation that the cavity would normally provide, you use thermalite blocks. This is how it goes together. The outer wall is brick, concrete block and cement. Then the ground inside is levelled and blinded with sand, and the damp-proof membrane is fitted. Then I pour a 4-inch slab of concrete that makes the underfloor and protects the damp-proof membrane. Next, the inside layer of the footing wall is made up using thermalite blocks. Here they complete the retaining wall. Here they provide a support for the floor joists. Here they insulate the wall and support the timber frame. And here they've been notched to create a periscope-shaped air vent that provides ventilation for the underfloor space. On the top of this footing wall there's a damp-proof course, and then from this level upwards it's possible to build in timber and hempcrete. The timber frame goes on in sections, starting with the timbers that fix the frame to the wall and define its position. And then the roof is fitted. The frame is then solid enough to put up the brick cladding. And my neighbours can breathe a sigh of relief because I'm out of their yard. I then fit some floor joists, and then finish the inside of the footing walls with cork insulation slabs. There's a couple of brick pillars that need to be added to the front of the structure either side of the doors. This is more of a decorative feature than anything structural. And at this point I've also got to do all the wiring for the extension and have it certified, which I think is going to include moving the consumer unit. And then, boom, I fill in the walls with hempcrete. The roof build-up starts with an internal layer of wood wool board. This is breathable and acts as a good backing for lime plaster. The rafter spaces are filled with sheep's wool insulation. On top of that goes the sarking boards, and these act as a breathable membrane and an extra layer of insulation. Then 40mm battens, then a layer of ply to create a ventilated roof space, and then finally a zinc roof with a solution for the skylight and the guttering. The design for the floor isn't quite completed yet, but I'll probably stick in some underfloor heating. I'll make some very highly insulated doors, plaster the structure on the inside and render it on the outside, and then it'll be looking good. What's that? You're wondering why there aren't many gags in this episode? Tough crowd. Okay, look, There is just one thing I should probably share with you, but it's really no laughing matter. Have you noticed the resemblance between the extension and the Millennium Falcon? Here it is from the front. And from above. And here it is from one side. Coincidence? I don't think so. When I searched it, the first thing comes up is the Star Wars databank. It says, despite her humble origins and shabby exterior, the Millennium Falcon has played a role in some of the greatest victories of the Rebel Alliance and the New Republic. The Falcon looks like a worn-out junker, but beneath her hull she's full of surprises. It's uncanny. But the strangest thing of all is I didn't realise. My friend Andy MacDonald had to tell me. I thought I was just responding to a set of criteria in the space to build an extension. But what was I really responding to? Doesn't look like it could make the Kessel run in 12 parsecs, but you never know.